Hi, welcome back to the Gabster channel. We have all been looking for this ideal power supply that is inexpensive, that is ready to plug in and use without having to buy transformers and put wire things and make your own. So what I did is I went and bought about 3 of them. I actually bought more, but some of them did not fare at all. But these are the ones that stood out, at least from where I looked. And these are the ones that has the little Studer Imitation 900 that I liked, that tested the best out of 10 different power supplies. If you haven't seen that video, I'm putting a link for it in the corner up here and also in the description, because it's a really great video to test different power supplies. This particular one has a dual outlet, so you can do 5 volts or up to 15 volts if you want. And it has everything. You got a small, nice power switch here, so it's all ready to go. Just have to plug in. It even comes with the cable that you need to plug it in from the back here, and even the power cord. So that was this one. This is a single version, and this one I thought we could use for like 15 volt. It's kind of nice LED, even tells you on this one the voltage. We'll talk about this later. It's an interesting story. And basically what I like about all these is the transformer was separate on the chassis than the board. And that's where we're going to talk about that as well. And it's pretty much the same board that I liked when I tested those 10 power supplies, because this one can go down to the 1 microvolt ripple level. And the third one is a little smaller one, and it has a built-in transformer on the same board, and it's a little bit more compact. It might be a little cheaper to ship as well. I forgot to mention that the dual one are actually, these are independent two rails power supplies. Often you get dual, but they are not. They are connected together, or they have a common ground. These do not share a common ground, and they're completely independent, and even the transformer has 2 separate windings for them. So this is a true independent dual power supply. And what you can use this, for example, if you are building my Gabster TD1, if you guys are not familiar with this, also I'll put a link for it in the corner up top and the description. And if you are using for my Gabster TD1, you are going to need a +5 and -5 volt. And this is a perfect power supply to do that, because not too many can actually do that. And the other one, the single one, would, for example, you can use it for the 15 volt, and that would work perfectly for that. And or if you have a different application and you need that plus and minus feature, or you might just want 2 separate power supplies. On top of that, what I like about these is actually there's a couple pots here, so you can adjust, fine-tune the voltage. So for example, if you want maybe 15.5 volt or 5.4. Anyway, but let's actually gonna put all these to the test. We're gonna test them on my little spectrum analyzer here, and then see how they actually test. First, let's try this little guy and see how it measures. So I have it plugged in here, and we've got a little small load with a little light bulb going, and this is the ripple on this little guy, and it's not good at all. We have a big spike here of close to 6 millivolts, actually, might even be more. There's quite a few little spikes as well here. Nothing bad, but you know, there's quite a few of them. Putting a CRC filter on it, let's try that. I mean, it's going to make it better, but not, you know, this is not a miracle device. It's not going to be. Let's see what happens. So I put a CRC filter. Wow, actually, it kind of cleaned up nicely, but still, we've got about 8 microvolts here. I guess it will work if you put a good CRC filter on it, and you're okay with, you know, 7-8 microvolts, which is not bad. Actually, it's still low. But again, we're trying to get something that not too terrible from the start. But that's a good testament for the little CRC filter that I've designed. If you guys haven't seen that video, I'll put a link in the corner up top and the description below as well. So this is the inside of the dual voltage power supply. So it's got a really nice roomy case, so it's not, things are not too cramped, too close to each other. I like a little bit of separation between the transformer and the board. And it uses the exact same board that I liked using before, that I've tested. If you have not seen this video, again, I'm going to be putting a link for it in the corner and also in the description below, where I talk about when I tested 10 different power supplies. So this is good. This has a dual voltage, so you've got two independent power supplies and also supplied by two independent windings on the power supply here. So it says, let's test it out. Does it measure really well? And here we are, we have it on load. We put a little small light bulb to just as a load. It's kind of simulates what we usually kind of load it for around, 100, 200 milliamps at the most. So that's very close. And let's have a look to the chart. And that looks pretty darn decent. It's actually quite good. What we have is, we have like a general, just a little bit of bouncing up and down around, just up to like 5-6 microvolt in this area. And that's because we have a little long lead here to supply the power to the system there. So let's plug in our handy dandy CRC filter here and see if that can fix that little tiny issue, which is not a big deal. I mean, this is already pretty good as it is, but remember, we're trying to get this perfect power supply, and that's the whole idea here. And here we are. Let's just zoom in a little bit more. And look at that, that's just perfect. We got rid of all the ripples, so we're all below the 1 microvolt level, just like that. And so combination with a good CRC filter, it works really good. Or even just put a few capacitors just close to the load and it might be also good as well. Now let's test the last one. This is a single one. It's from the same company that makes the dual one, which is a really good one, as we just saw. So let's see if this one is the same. Now, the only difference with this one was it has an LED display at the front. This power supply, when I tried to test the ripple on it, like I did in my other videos, it did not test so great. It has a lot of ripple pretty much everywhere, frequency, and it's about over 100 microvolt. So trying to see why. Looking into the inside of the power supply, I noticed that the transformer is quite close to the circuit board and also the big capacitor. So I thought maybe it's causing some noise that way. So I took the transformer out to see if that makes a difference. And as we see here, we still have a lot of noise. That didn't change anything. If we plug in some capacitance close to the load that is not far from it, or you can use one of my handy dandy CRC filter. If you haven't seen this one, I made a special video on this. It shows you how this simple system can work. And you can see how it went from the big chaos to a lot better. But that's still not good enough. Now I kept thinking to see what's the difference. I noticed that this power supply has an LED display that displays the voltage. And as soon as I disconnected it, I already desoldered it and took it out. Now check out what happens to the ripple. Pretty much all gone, and we're much smoother now. We're back down to normal. So yeah, so basically no LEDs, take that out. And if you have either a CRC filter or even just a couple capacitors close to the load, it's going to make a big difference. And the moral of the story is that if you have an LED on your power supply, you need to take it out because it's definitely going to be causing you problems. If you guys seen, because this is they're supposed to work with every voltage possible. So basically they have little buck converter that converts your power to like maybe 3 volts to function the system here. And that's creating a havoc of noise on your power supply. So you want to disable that. If you've seen my video that I've done before on dimmer switch, how they can wreck your system. And look what happened when I turned the dimmer switch on. If you haven't seen that video, I'm going to put a link of it in the corner on top and at the description below as well. Check it out because it really shows you how dimmer switches can wreck your system. And this is the same thing. It's kind of like a dimmer light bulb that's kind of wrecking your power supply, creating lots of frequencies pretty much everywhere on the system. And you can really see it like I see it here on your chart. Like it's just a mess. And now disconnect the LED and disable that, and we go back to here. You could see now we're down to 1 microvolts. There's only one thing left, and I might need your help, everyone. Maybe comment below. None of the two have the chassis grounded to the ground, and even though the R-core transformer has a copper thing around it, even the R-core transformer has a ground wire. I thought that the ground wire that goes into the R-core transformer should be connected to the shield here and to the chassis. And when I test it with my tester, it is not. But the case should be grounded. I noticed also that the chassis and the copper here are connected together. So if we ground the chassis, this will get grounded as well. I did power it just to make sure nothing bad is happening. And it actually worked good and nothing changed on the spectrum analyzer. It remained the same. So this way, you're actually, I think that's the way it should be. We should probably run a wire from the ground to the base here, to anywhere basically on the chassis. You could put it on one of the bolts or anywhere that you feel like it. It could be as close as even this one here, but you avoid being too close to the output, so maybe just somewhere on the chassis would work well. But let me know in the comments below, what do you feel that this ground wire is not connected to the, when it comes to the shield? Shouldn't it be? Don't they usually are? Anyways, so that gives you an idea of the inside of this. But overall, actually, I do like it. Just a couple little things, but otherwise, it's actually pretty good because it's all contained in one box. You just plug it in and you go. All right, so the conclusion is that this dual power supply is really excellent if you get that exact same one. And again, I'm not affiliated with these guys. And what you can do is basically, there's not much to do for it. Actually, you just have to buy it and plug it in and you're good to go. If you want to, you can ground the chassis. The chassis is not grounded, by the way, and I talked about that in my video. But other than that, it's got a ripple down to 1 microvolt, especially if you add a few capacitors close to the load or use like my CRC filter. Now the second one, which is the single version of that same, you buy those actually from the exact same people. They sell them in a single and a dual version. The single version has an LED on it, and I don't know why, but the other one doesn't. But that, like we found out, turned out to be very problematic. So the first thing you want to do is you open the case. To open the case, you just unscrew the top screws on front and the top screws on the back. Don't do all the screws. Then you can just pull the cover off, and you just have to yank that little cable that goes to the LED, or if you don't want to do much, just pretty much cut it. That's all you have to do. And but other than that, once you do cut it, then this can go down to the 1 microvolt level, especially if you add, again, some CRC filter or some capacitors close to the load, because whenever you have a long power cord, you're basically going to introduce noise, and it's good to have something closer to the load to reduce that. But otherwise, it's a pretty good power supply. And lastly, this one, I still don't know what's going on here and why this one have ripple all over the place. I don't have time to really look into it. I mean, if I want to design a power supply, I might as well do it myself. But if I want to buy something cheap and ready to go, might as well be ready to go. This one isn't. Now, if you have bought this one, it's not that terrible if you add some capacitors closer to the load, or the CRC filter. It seems to do quite wonders actually to it. It completely took away the 10K ripple, but still wasn't exactly as perfect as we would like it to be. But you can work with it, it's not that bad. I'm going to put in the corner up here my video where I tested 10 different power supplies. In the corner here, I'm going to put a video on how you can test your own power supplies. There'll be a speaker in the middle if you'd like to subscribe. If you'd like to support my Patreon so I can buy more of these power supplies and show you things and buy other things, it's as little as $1. You can subscribe and help the channel. Take care, and I hope to see you again.